Oh, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radiolab.
From
WNYC.
See?
Yeah.
Here you go. Huckadoo. Here you go. What are you eating?
It's an apple.
Can I have a bite of the apple?
No.
Why not?
Too yummy.
It's too yummy? It looks so yummy.
I'm Latif Nasser. This is Radiolab. And that is my 4-year-old son who every single night before bed eats an apple. Which seems a little silly to say, just because honestly, that's something I never thought twice about.
All right, I'm good.
Yeah.
Great.
First of all, can I just say, I had the conversation I'm about to share with you.
It's an honor for me to read this book.
Thank you.
So this is Nicola Twilley. She's one of my favorite living science writers. She has written for The New Yorker, The New York Times Magazine, Wired, among other places. She hosts a podcast called Gastropod, and she just came out with a book that I had been hearing about from her for years, honestly, ever since I first met her.
You were already working on stuff. That was like
Oh, no.
That was like 10 or more years ago.
I would say in total, it's coming up on 15. I really don't recommend that to anyone, but
it's an amazing book. It's called Frostbite. It's all about the crazy things that we do to our foods to get them from the farm to our table. And as the title suggests, a lot of the book is about refrigeration, which is, of course, why my son can eat a crunchy apple in January. But our conversation actually ended up going way beyond refrigeration to some pretty surreal places and even psychedelic-seeming technologies.
oh yeah. We are truly playing God with fruits and vegetables.
So today on Radiolab, I want to play this conversation with Nicola for you. It takes us from apples to salads to meat. It takes us from cold to warm. It completely changed my idea of what it even means to call something fresh. But it started off actually just talking about all about the different refrigerated places that our food lives on its way to our mouths.
Well, this is the food superhighway. It is the sort of behind-the-scenes series of spaces that we've built for our food to live in and move around in. And it's basically invisible and out of sight. And yet that is where roughly 3/4 of everything that we eat on average spends time in that space. So yeah, that's a good way of thinking about it. The other way of thinking about it is sort of a time machine of sorts.
Go say more about that.
Yeah, well, because this is a funny thing that it took me a while to realize, but the way refrigeration works is it just makes everything slow. This applies across life.
But like
people,
just in general, or like on a cellular level?
Well, so it's from the largest scale to the smallest scale. So when you work in a refrigerated warehouse, you are slower at doing the same tasks measurably than someone in an ambient temperature warehouse. But all of your cells are also working more slowly, individually, and your brain is firing more slowly. It's just slowed down reality, and that's how it preserves food, too. It just stops fungi, microbes, bacteria by slowing them down. And then for things like fruit and vegetables, which like us are alive, it just slows them down like it does us. So they breathe more slowly and they last longer.
Okay.
So that is literally how cold works. It's a time machine. It slows everything down.
Now, I have to say, at this point, I honestly was not even thinking about the fact that fruits and vegetables are alive. But Nicola said, as soon as you pick them, they're starting to die. And the whole point of the food system is to
prolong the death processes of fruits and vegetables.
And she says when it comes to what we do to delay that process, refrigeration is just the tip of the iceberg, so to speak.
Oh, yeah, sure. Yeah. Okay.
And to explain, she actually told me a story that goes back to the earliest uses of refrigeration back in World War I.
So during the First World War, Britain realized that it didn't have enough food to feed itself, and there was sort of a mass panic. So they set up this institute, and they start to work on apples. Long story short, they're able to keep apples refrigerated for a year.
What? I didn't even know that's possible.
Oh, yeah.
Like, I get like a month or 2 months or something like that.
Oh, yeah.
Okay, sorry, I cut you off.
England. They figured this out.
Okay.
Their first lot of Granny Smiths are coming out. You know, they went in the autumn. They're coming out in the spring. There's headlines in the newspapers. Wow, wow, wow. But there's a problem.
Okay.
It turns out that elderly apples seem to emit something that is prematurely aging younger apples.
Spoiling their younger competition?
Exactly. But they're also messing up other fruits and vegetables. They're causing pea shoots to grow all knobbly. They're turning bananas into mush. No one can understand it. Like, what is this apple power that...
And it's something that's in the apple? Like
Well,
that...
It seems to be in the air around the elderly apples.
Okay.
Total mystery.
But what they eventually realized is that in the air floating around these elderly apples is something called
Ethylene.
Ethylene.
It's a hydrocarbon.
It's
And
one of
so
the components in
reason it was
oil and
coming
natural
from-
gas. And in fact, a Russian scientist earlier in the late 1800s had discovered that plants and in particular trees living and growing near gas street lamps would not grow as well. They were being poisoned. So it was known, ethylene was, as a sort of plant poison. But
weirdly, the same thing that the street lamps are emitting that is a plant poison, the plants are emitting themselves. How is this possible? But it turns out that ethylene is something else as well. It's actually a plant hormone.
plants, it turns out, use ethylene as a sort of developmental signal sent between cells.
So what it does is it tells a plant to move on to the next phase of its existence. Like if you spray ethylene over a field of pineapple plants, they all burst into bloom.
It's like puberty.
Exactly. The way that, in our bodies, testosterone might tell your hair to grow.
Right.
Like, the apple is using ethylene to tell its little, apple cells, hey, time to lose your crispiness and your crunchiness and become mushy so that a bear will pick you up and eat you and scatter the seeds in the forest.
So the British scientists figure out how to block ethylene, which for these apples that they're trying to store, it's like they're telling them,
you must stay in eternal youth.
and it solves the rotting apple problem.
But then they figure out how to use it for other plants, which is also turns out to be an amazing tool because it turns out to be the key to ripening bananas. So a banana, if you want to harvest a banana and it grows in a tropical country and you want to eat it in a non-tropical country, you have to harvest it when it's green and unripe and refrigerate it. And then you get it to the destination. It's not going to ripen on its own.
Oh, I see. I knew that part, but I didn't know that's like the switch to turn it on the other side.
That's the switch. Ethylene is the cue to the banana to be like, great, now I'm going to ripen and become a yellow squishy banana. And then you have like 48 hours to get it to the grocery store before it, starts turning into banana bread.
Yes, that's right. Right.
So,
So you said so it ripens apples, it ripens bananas.
It ripens bananas and avocados. It keeps celery white, prevents it from going green. It turns lemons yellow and oranges orange. I mean, every lemon you buy, for example, has typically been blasted with ethylene to be yellow. And it turns out if you expose root systems to ethylene, they get bigger. So tomatoes, for example, will have their roots dipped in ethylene before they're planted. I mean, our whole fruit and vegetable world is built on using ethylene to control fruit and vegetable responses.
They should just give us that to do that at home. They should just give us the green bananas and a little pack of ethylene, and then you could just do it at home.
Well, I think here's the problem, Latif. Turns out to also be super fun to huff.
No.
Yes.
Okay.
It was like the party drug of the 1920s. It was...
Really?
Yes.
Real quick, the story is that these scientists who had discovered ethylene,
They did what scientists always do. They huffed some of it themselves. And it's an amazing paper. You can download it, and read it. And it's the Journal of the American Medical Association.
And what does it say?
They're like, we felt a sense of well-being and exhilaration, but you can tell that they are having the time of their life. One of their friends just can't stop giggling, which they report. One of them says his report is like, I felt such bliss that I would be satisfied to lie down under the influence of this drug for the rest of my life.
This is just one more reason to buy apples,
Well, so the reason I got...
So just one more historical note about ethylene, and then we'll get back to food, I swear. I just can't resist. So it turns out that as Nicola was researching this book, she came across a very fascinating theory.
The ethylene is what the priestesses at the Oracle of Delphi were huffing.
What?
The Oracle at Delphi, of course, was the one of the most famous oracles of ancient Greek history, and anyone who would go there and ask for advice. When should they plant their crops? Should they invade their neighboring country? Whatever. And the way it worked was a priestess would hear your question. They would go down into this little subterranean cave under the temple where there was a spring, and they would, quote unquote, commune with the oracle and drink from the spring. And then they would relay a message to a priest who would then interpret that back to the person who was asking the question.
Anyway, a couple decades ago, the Greeks were wanting to build a power plant over the same area, and a geologist who was studying that land discovered that this area had oil in it underneath the spring, and it seemed like some of the ethylene was sort of off-gassing into that spring and into that cave. So the theory is...
the priestesses at Delphi were huffing ethylene. They were talking in excited and incoherent sort of gibberish, and then the priest was relaying that message. That's what was happening. This plant hormone that is a hydrocarbon that is, turns out to also be the real oracle.
Right. That's the real oracle.
But yeah. It's also, I was like, wow, ethylene is so powerful. This is incredible. And then it turns out that the fruit and vegetable use of ethylene is like this tiny, tiny little drop in the ocean because...
compared to what?
Plastic.
Huh.
All plastic is made using ethylene. It is the building block of polyethylene, which is everything. So basically, this is why ethylene turns out to be the most produced organic chemical in the world.
Wow.
Because it is the bedrock of all plastics. And so we're making this oracular fruit and vegetable messenger. We're using it to make plastic bags.
We're going to take a quick little break. When we come back, we're going to shift from apples to arguably an even fresher food. And we're going to talk about, believe it or not, plastic bags. This is Radiolab. I'm Latif Nasser. We are back talking to Nicola Twilley about how the food we eat gets to our tables. We are going to move away from apples and ethylene and ancient Greek prophecies to a kind of surprisingly futuristic technology stolen partly from nuclear submarines in the form of a certain kind of plastic bag.
Salad bags.
That holds salad.
Well, first of all, one thing to understand about salad is until the 1920s, no one bothered with it. It was pointless.
What do you mean?
Well, at this point in human history, people are moving to cities in the United States. And it's really hard to get people a salad. when it's not grown nearby and you don't have refrigeration. So salad was just really like, if you were super rich, you might have a nice salad of an evening, but it was not a part of people's lives until the iceberg variety is discovered. And it's sturdy enough that if you bury it under a crap ton of ice, you can ship it across the country and you're going to be able to sell it.
Which is where it gets the name iceberg lettuce.
Because as it travels, it's just these train cars full of lettuce covered in a mound of ice. So iceberg is the only lettuce that most Americans could eat for most of the 20th century. And then what happens is a guy called Jim Lugg.
So in the 60s, the 1960s, Jim Lugg was working for a salad baron in the Salinas Valley in California. And he was trying to help them figure out how to sell more salad and send it more places. Now, right around the same time,
Whirlpool, the company, has come up with some new technology that was spun out of Cold War nuclear submarines. Cold War nuclear submarines stayed underwater for a really long time, and so they had to get really good at controlling the atmosphere.
Like within the sub.
Yeah.
Yeah.
You know, how much
Yeah.
oxygen and how much carbon dioxide. And Whirlpool had developed controlled atmosphere warehouses. So
when Jim Lugg learns this, he's like, wait a second. In addition to keeping things cool, if I could control the atmosphere of the salad, if I could control how every bit of the salad is breathing, maybe I could slow down its decay process.
And he's like, we need to take this thing that you can control the atmosphere in a building, but for a bag.
Because then there'd be all kinds of delicate, leafy salads that could survive better being shipped across the country.
And he comes across a polymer scientist who's like, oh yeah, differentially permeable membrane. That'll do it.
Okay.
And so what differentially permeable membrane is something that we have in every cell in our body, which is it's just a membrane that will, know to let out oxygen or take in oxygen preferentially at a particular rate.
So in the mid-1970s, these scientists, taking inspiration from the cells inside living things,
figured out how to do it. You layer together these membranes, one that lets in oxygen at the right rate, one that lets out carbon dioxide at the right rate, one that lets in water vapor at the right rate or out at the right rate. You just kind of sandwich these all together, plus, a layer for the label and a layer for, some kind so these things are like a minimum of 5 layers, sometimes more thick, delivering a controlled atmosphere inside that bag. It is a respiratory apparatus for lettuce. It is not a salad bag at all.
That is crazy.
But your point.
and I gotta say, I just grabbed one of these just a second ago from my own fridge, and it feels like I'm holding something between an advanced technology and a living cell.
This is one of the things that, people who study fruit and vegetables sort of impressed upon me is a baby lettuce, you're harvesting it when it's so tiny that there's only maybe 5 true leaves on the plant. And it is breathing so fast. It's it's a little baby.
Oh,
it's
my God.
And because it's breathing that fast, it is going to die. It's going to burn through all of its resources and it'll turn into green slime. So you have to slow down its breathing.
You're giving me a vision of someone in a grocery store with the defib paddles on a little piece of spinach or something.
It's life support. Honestly,
Yeah.
when you visit the labs of the people who are doing this research,
Yeah.
all the fruits and vegetables are hooked up to monitors and you can measure how fast they're breathing. You feel like you're in the ICU.
That's so weird.
It's so weird. I never had a sense of my fruit and vegetables being alive. And now I'm sort of wow, are we taking care of you? Are you okay? You need something?
Yeah, right. Seriously.
Anyway,
Point is, this seemingly simple plastic bag,
it was this transformative salad technology. People went from eating iceberg to the salad revolution we live in now. Because you had this life support technology in the form of a plastic bag.
Who would have thought that was more than a bag? That just looks like a bag.
Well, so this is actually a really interesting bigger point is because the food industry goes to this enormous effort to keep our food alive, right? We are really good at prolonging the life of fruit and vegetables. Like, you know how all those Silicon Valley billionaires are like injecting themselves with young people's blood and whatnot?
Yeah.
And, like those regimes have nothing on what we have figured out for fruits and vegetables. But at the same time, they don't want you to think about that because people are weirded out. Like, what do you mean my apple's a year old?
Right.
What do you mean my lettuce leaf is a month old? I don't want that. That's not right. That's not fresh.
Right.
And so they have to go to all this effort and then make it invisible. Tell it like it's fresh. It was just picked yesterday, you know?
Right.
Of course it's fresh. And so one of the most exciting technologies I came across it's like Jim Lugg 2.0, Mr. Salad Bag 2.0. He took, something that was a building-size technology and made it a bag-size technology.
Yeah.
These guys have taken something that's a bag-size technology and made it like a nanoscale spray-on layer-size technology. So they have figured out how to create this differentially permeable membrane, this layer that lets in the right amount of oxygen, lets out the right amount of carbon dioxide. They have figured out how to create a spray that structurally does that out of lipids.
Lipids are basically just like a fat molecule in our body, and they're the actual thing that cell membranes are made out of.
Literally.
Wow.
And it's the way the guy who invented it, he spent his PhD figuring out how to spray paint particles on solar panels to make them more efficient at harvesting light. And it has to do with how they dry and the little structures that assemble as they dry. Same deal with this spray on fruits and vegetables is to do with how it dries and the little structure it creates as it dries.
So so you would just spray an apple and then you wouldn't have to refrigerate
Correct.
it?
So when I went there,
Whoa.
I went into a room where there were red bell peppers at room temperature, and they had been there for 8 weeks. So if you left a red bell pepper on your countertop for 8 weeks, you can imagine it would be a pretty sad looking thing.
Shriveled and
not good.
And
maybe even moldy.
Yeah.
Not something you were going to eat.
Yeah.
And the comparison ones, that hadn't been sprayed, that's how they looked. They were gross. You weren't going to eat them. The ones that had been sprayed, you weren't going to like cut them up and dip them in hummus. It wasn't like crudité platter time.
Okay.
But it was definitely stir fry time. It was like they were fine,
Huh.
They were the kind of thing you'd look at in your vegetable drawer and be like, I should use that.
And this thing doesn't have a taste?
No, it's a nanoscale layer of something that is a food. Like it's like a fat. So it's not, but it's, people are like, oh, you're spraying it in fat. It's like 0 calories. It's so thin. It's not a chemical. I mean, it is a chemical in the sense that everything is chemical, but it's not a like weird chemical in the sense that people, when you tell people it's a coating, they think of like the wax that you get on lemons and
that's what
stuff.
I was thinking of. Yeah.
No, I licked these bell peppers. There's nothing.
Okay.
There's nothing.
As I usually do around bell peppers that I see in the wild.
I asked permission first.
Oh,
but
yeah.
So, and at the moment, listen, they use this technology and they use it to just extend shelf life. So you can still refrigerate the bell pepper and then this just makes it last a little bit longer. The same way that salad greens still go in the refrigerator, but the bag makes them last longer. But the thinking is, in parts of the world where you don't have a refrigerator, or for fruits and vegetables that don't work in the refrigerator, like if you could spray this on them and keep them fresh for longer that way.
Yeah.
I mean, it's.
And you think this could scale?
Oh yeah. You have to figure out for every single different fruit or vegetable what's the right breathing rate. But they have a production line to do that. They're in commercial scale production. And here's the interesting thing of convincing people that this is a good idea. People 100 years ago thought refrigerated food was dangerous and immoral.
And now we're the opposite,
Yep, now we're the opposite. I mean, there's technology as well that's enabling that same different technology, but same idea for meat.
Whoa, seriously?
One of the consultants I spoke to was like, listen, we might get to a stage where we're shipping meat around the world with this technology. It's not refrigerated, but then it's sold out of the chill cabinet at the supermarket so you don't freak out, basically. That's because, I mean, for example, that's what happens with soy milk. Soy milk doesn't need to be refrigerated. Right. It just is because people think that milk should be cold. But the idea of buying non-refrigerated meat, I mean, I don't, even my...
That would be dicey. That feels dicey.
Terrifying.
But you think that's possible? There are people doing that. There are people working on that.
They have product. Like, it's about scaling it up. They're further behind, and they're also introducing their product first into restaurants because consumers are freaked out, but restaurants...
Right.
You know.
Restaurants are like, we'll try it. It'll cut our bottom line.
Exactly.
It does. It did give me just as you were describing it, it did give me a little bit of the creeps. Like, it just feels weird. Like, you're like, that should be rotting, but it's not rotting.
But that's what we all thought about refrigerated food.
I know. It's so funny. It's so funny how quickly that becomes natural.
Totally.
So that was my conversation with Nicola Twilley, whose insights I always find to be non-perishable. Her book is called Frostbite: How Refrigeration Changed Our Food, Our Planet, and Ourselves. Thank you to Nicola for coming on. And if you want to hear more from her, besides the book, you can also check out her podcast called Gastropod. Big thank you to Jim Lugg and Jeff Wooster, who we also talked to about lettuce bags. This episode was reported by, let's be honest, it was reported by Nicola Twilley, but also Maria Paz Gutiérrez and myself did a little bit of reporting. It was produced by Maria Paz Gutierrez, fact-checking by Emily Krieger, and edited by Alex Neeson. Okay, one last tiny thing, I swear. We often, at the end of the episode, we say the name of the whole staff of the show because we are proud of the people we work with. But the people we don't mention is there is a whole station who works with us here at WNYC, and one of those people who works at the station who was integral to getting this show out from week to week. He is leaving the station, Stephen Gagnaram. He is one of the most skilled and consistently competent people any of us has ever worked with. He was responsible for IT and fixing our computers all the time, which happened, I mean, I can't even count. So anyway, thank you so much, Stephen. We really appreciate you, and we'll miss you. I will catch you in, if it's an apple a day, I will catch you back here in 7 apples. In the meantime, stay crunchy, stay crispy, stay healthy.
Hey, I'm Lemon, and I'm from Richmond, Indiana, and here are the staff credits. Radiolab was created by Jad Abumrad and is edited by Soren Wheeler. Lulu Miller and Latif Nasser are our co-hosts. Dylan Keefe is our director of sound design. Our staff includes Simon Adler, Jeremy Bloom, Becca Pressler, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Nyanan Sambandan, Matt Keelty, Annie McEwen, Alex Neeson, Sarah Kari, Sarah Sandback, Anissa Vitsa, Ariane Wack, Pat Walters, and Molly Webster. Our fact checkers are Diane Kelly, Emily Krieger, and Natalie Middleton.
Hi, my name is Teresa. I'm calling from Colchester in Essex, UK. Leadership support for Radiolab science programming is provided by the Gordon and Betsy Moore Foundation, Science Sandbox, a Simons Foundation initiative, and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.